discussed about the definition of relation, domain and range of relation, different types of relations. Today I will start different types of relations one by one with examples. Types of relation. Types of relation. Number one, we consider first reflexive relation. Now we define what do you mean by reflexive relation? A relation R on a set X, that is non-empty sets, is said to be a reflexive relation if every element of set X is related to itself, then R is reflexive. This imply by X comma X belongs to relation R for all X belongs to capital X, that means set X. Note, point to be noted here, a relation R on a set X is non-reflexive if there exists an element X belongs to set X such that X comma X does not belongs to relation R. Here I would like to clarify this matter, reflexive relation, and when the relation will not be a reflexive. Both have, this is the conditions. So we construct example. A relation is reflexive and not reflexive. How to identify the given relation is reflexive or not. So we construct example here. Let set X is equal to 1, 2, 3, 4 be a set, then R, we define R1. R1 is the first relation we establish on the set X. 1 1 2 2 3 3 4 4 1 2 1 3, this is so. And another R2 relation we establish here. 1 1 2 2 3 3 4 4 4 4 4 2 4 2 4 2 4 3 4 and so on. Another relation R3 1 1 2 2 3 3 3 3 3, 1, 4, 4, 4, and so on. Which one? R1, R2, and R3. R1, R3, R1, R2, R3 is reflexive or not reflexive? How to identify? Here R1 is reflexive because 1, 1 and 2, 2, 3, 3 and 4, 4 all are present in this relation R1. Hence R1 is clearly reflexive. R1 is clearly reflexive relation. R2 is not reflexive. What is the reason behind this? R2 is not reflexive. R2 is not reflexive because 4 is the element. 4 element belongs to set X, but 4 does not belong to R2, and this is the reason behind this, and therefore R2 is not reflexive. Similarly, R3 is also not reflexive relation. What is the reason behind this? Here 2 does not belongs to R3 while 2 belongs to set X. Therefore 2 must belongs to R3. Okay. Next we consider identity relation. What do you mean by identity relation? Let X be a set, then the relation IX. I means identity. This indicates identity relation over set X. This is the meaning of IX is equal to XX such that X belongs to capital X, that means set X, on set X is called identity relation on set X. We can say this matter in other words. We can say in other words as IX on X is called identity relation if every element of X is related to itself only, here point to be noted only, but in case of reflexive relation not available here, only not. This is the difference between the reflexive relation and identity relation. Here itself, any element related to itself only, while reflexive relation R on set X is said to be reflexive relation if every element of set X is related to itself. But here in the case of anti-element, every element of set X is related to itself only. This is the difference between the reflexive and identity relation. I would like to clarify this matter, identity relation, with the help of examples. Okay, to take example, let x is equal to 1, 2, 3 and 4. Now we construct the different types of relation, like as r1 is equal to 1, 1, 2, 2, 3, 3, 4, 4. R2 is equal to 1, 1, 2, 2, 3, 3, 4, 4, 1, 3. R3 is another relation established here. 1, 1. R3 is equal to 1, 1, 2, 2 and 4, 4. This is the three types of relation R1, R2, R3 we have established here on set X. Okay, now we have to clarify R1, R2, R3, which one is identity relation. So first of all, we see here 1, 1, 2, 2, 3, 3 and 4, 4. All are same element related to itself only. Itself only. 1, 1, 2, 2, 3, 3, 4, 4. And therefore R1 is clearly identity relation on set X. R2 is not identity relation because 1, 3 is extra, not itself. 1 related to 3, it is not it is not possible. Element related to itself only. 1 related to 1, 2 related to 2, 3 related to 3, 4 related to 4. This is the meaning of element related to itself only. But here 1 related to different element, different 3, actually not possible, and therefore R2 is not identity relation. R3 is not identity because this is what is the reason behind this. R3 is not identity relation because 3 belongs to set X. So 3 belongs to 3 is not identity relation because 3 belongs to set X, but 3 does not belongs to 3, and this is the reason behind this. R3 is not identity relation. Okay, I would like to add one thing more, that is the difference between the identity relation and reflexive relation is that identity relation on a set X is always reflexive relation on X. However, a reflexive relation on X is not necessarily the identity relation on X. Now we write it. Identity relation and identity relation on a set X, on a set X is always reflexive relation set X. However, a reflexive relation on set X is not necessarily identity relation on example. We construct example to clarify this thing. Example, let x is equal to 1, 2, 3 and 4. R is equal to 1, 1, 2, 2, 3, 3, 4, 4, 1, 4. Here we see that R is a reflexive relation but not identity relation. Here R is reflexive relation but not identity relation, because one four elements belongs to R, which is extra element, therefore R is not identity relation. So we conclude that a reflexive relation is identity relation, but converse is not true. Every identity element, another type of relation which is a symmetric relation. A relation R on set X is said to be symmetric relation if and only if x comma y belongs to set R. This implies y belongs to set R for all x and y belongs to set X. Or we can write it as follows: x comma y belongs to R means x is related to y. This implies y related to x for all x comma y belongs to capital X set X. Example, let x is equal to 1, 2, 3, 4. R is the relation 1, 2, 1, 3, 2, 1, 2, 1, 1, 3, 3, 1, 1, 4, 4, 1. Here R is a symmetric relation because 1, 2 belongs to R. This implies 2, 1 also belongs to R. 1 2 belongs to R and 2 1 also belongs to R. X comma y belongs to R. This imply y comma x belongs to R, and similarly 1 3 belongs to R. This imply 3 comma also belongs to R. 3 comma also 1 belongs to R. 1 4 belongs to R. This imply 4 1 also belongs to R. Hence R is symmetric relation. Remaining type of relation like as transitive relation, equivalence relation, empty relation, universal relations will be discussed later on or in next lecture in my video classes.